All right, so we are going to be working on the properties of a parabola. So the first thing we want to start off with is just kind of making sure that we refresh our memory on the standard form of a parabola. Ax squared plus bx plus c, okay? And so we talked slightly last class about how can you tell when a parabola opens upward or downward. And if you recall, it is by looking at the a term in your equation, the coefficient in front of your x squared term. When a is greater than 1, or greater than 0, excuse me, then a is positive. And if a is positive, then it opens upward. Okay, so your parabola would look like this, opening upward, okay? If that a is less than 0 or negative, then it opens downward. Okay, so it's going to open like this. And so that a in the front tells us a lot about our function right away. In order to graph them, we need to know where the axis of symmetry is, and so the formula for the axis of symmetry is the opposite of b over 2a. That's how you find the axis of symmetry, okay? So that's how I would find this axis of symmetry on this graph, and we will finish graphing this in a little bit, but that's where the axis of symmetry would be placed, okay? To find the vertex, you would agree that I would have to come over from 0 as far as my axis of symmetry in either direction. So the x coordinate, which we're going to call h, is going to be the same as the axis of symmetry. So the opposite of b over 2a is how I find the x coordinate of my vertex, which we're going to call h right now. And the reason for that is because in subsequent chapters, hk are the letters that we're going to use to indicate a vertex of some sort of function. So we might as well get used to using hk right now. And we'll talk about that more as we go along. So I have for you the vertex, negative b over 2a, or opposite of b over 2a. And again, thinking back to the last chapter, when we were looking for an ordered pair on a graph, we would find x, and then we would take that value for x and plug it into the equation and solve for y. And so that's exactly what we would do here. We will take whatever we get for x, and we're going to use the negative b over 2a to find the x. Whatever we get for that, we're going to plug it into the function and chug out the answer. Okay? And then the last thing you need to know is that the y-intercept is always x is 0, y is c. What do I mean by that? Well, if you're looking for any point on the y-axis, every one of those points is going to have x is 0. And then y will be whatever up or down we need to go, but x will always be 0. And so when you plug 0 into a standard form equation, this term will be gone, the quadratic term, because this will be 0 times whatever number is here is going to be 0. And the linear term will be gone as well, because any number that I plug in here, I'm going to multiply by the coefficient b, and it's still going to be 0. And I'm going to be left with this value c, 0 plus 0 plus c. So anytime I plug in 0, the answer will be c. And so c is the y-intercept. You can go right to the equation, pull out that number, and that's where it crosses the y-axis. Okay? So those are some characteristics and properties of parabolas. Now we're going to actually use this example to try out these formulas, and we should be able to graph this parabola. This equation is this parabola, and we're just going to use it to prove that these things actually work. So the first thing you're going to do when you get ready to solve is you're going to say a is 1 because that's the number in front of my x squared term, and there's a silent 1 there. B is negative 4, and C is 6 because we need those for our formulas, okay? And I can tell by looking at the function that since the x squared is positive, that my function is going to open up. Okay, so again, my parabola is opening upward. To find the axis of symmetry, I do the opposite of b over 2a, so the opposite of negative 4 over 2 times a means I get 4 over 2 or 2. So my axis of symmetry is x equals 2. Remember we talked about the fact that that has to be written as an equation of a line. So here is my axis of symmetry at x equals 2, okay? The vertex, so in order to find the vertex, remember, the x-coordinate is the same as your axis of symmetry. You can see it here from our formula. So to find hk, that is the same, 2. And to get k, which is here, I'm going to take that 2 and plug it into the function. So I'm going to do f of 2. Original function, 2 squared, minus 4 times 2 plus 6. 2 times 2 is 4, minus 8 plus 6 is 2. So k is also 2, and that works out. Over 2 up 2 gives me my vertex. Remember, you start always from the origin, so over 2 up 2, okay? Got my vertex, got my axis of symmetry. Now I need my y-intercept. I know this is always 0, okay? And this number comes from c in my formula. And so c equals 6, which means it crosses the y-axis at 6. Okay, so on my y-axis it crosses at 6. The beauty of a parabola is that once you find a point on your parabola, you can always mirror it over and get a second point. So here it is, 2 units away from my axis of symmetry, so I'm going to go 2 in the opposite direction and find my other point, and it falls perfectly on my parabola. And so this particular parabola only has 3 points, but I'm going to always ask you to have a minimum of 5 points when you're graphing, and we'll practice that in a little bit. So let's scroll the page and just practice finding the vertices. So let's find some vertex coordinate pairs here with these examples. So again, to find the vertex, I'm really looking for hk, all right? And so A is 1/3, B is 0 because there's no linear term, and C is 1 because it's the constant. To find H, I have to do opposite of B over 2A. So opposite of B over 2 times A. That's going to give me 0 over, who cares, right? Doesn't really matter because 0 divided by anything is going to give me 0. So H is going to be 0. And then to find K, I have to do f of my axis of symmetry, which happened to be 0. So I'm going to do f of 0. And I want you to be really careful when you plug in 0. So we're going to do 1/3 times 0 squared plus 1. 0 squared is 0 times 1/3 is 0 plus 1 is 1. So I get the ordered pair 0, 1 as my vertex. Second example, A is 3, B is 12, C is 8. Again, I'm looking for HK, the vertex. To get H, opposite of B over 2A. So the opposite of 12 over 2 times A, which is 3. Negative 12 divided by 6 gives me negative 2. All right? And then to get K, I have to do f of negative 2. So I take this and plug it in. That's what we did here. Take 0 and plug it in. So 3 times the negative 2 squared plus 12 times negative 2 plus 8. I want you to be really careful when you are plugging in, sorry, I want to get a good color. When you are plugging in this x term, to use parentheses around the x terms. That's going to be really, really, really important. Okay, so again, I also want you to be very careful when you're evaluating these. Exponents comes before this multiplication happens. Exponents before multiplication. So you need to square that first, okay? So we're going to do negative 2 times negative 2 gives me positive 4 times 3 gives me 12 minus 12 times 2, or 24, plus 8. So I get negative 12 plus 8, or negative 4. So negative 2, negative 4 is my vertex there. Okay, let's try a couple graphs, and then you can go ahead and practice some. I'm going to scroll the page. So steps to graph a quadratic. Here we go. Here are the steps we're going to use. We're going to always start with identifying A, B, and C. So here's my equation. A is 1, B is 2, and C is 1. To find the AOS, we do the opposite of B over 2A. So the opposite of 2 over 2 times 1 is negative 2 over 2, which is negative 1. And remember, you have to write that as an equation. I'm going to be very picky about that, so be careful. X is negative 1. Here is my X is negative 1 axis of symmetry. Okay? And then, of course, I already know that, and all I have to do is plug it in. Sign errors will be your biggest nightmare if you're not careful. Use the parentheses around your x term. So x squared plus 2 times negative 1 plus 1. Negative 1 times negative 1 is 1. 2 times negative 1 is negative 2 plus 1. So I get negative 1 plus 1, or 0. So my vertex is at the point negative 1, 0. Backward 1, up nothing from my origin. There's my vertex. Once you have your vertex graphed, then you can steal another set of points, usually, when you can figure out what the y-intercept is. So remember, this is where it crosses the y, and you get it from C. Okay? So it crosses the y at C. So 0, 1 is where it crosses. So here is where it crosses. And since it's symmetrical, we can also get its reflection. So I'm going to reflect it over. And right now I have 3 points. That's not enough to graph my parabola yet. I need at least one other set. And so we have to choose another reasonable value. And so the question is, how do you decide what's reasonable? Well, if you think back to, again, one of the conversations we had just last class about the fact that when you're looking at a parabola, the first few points are usually packed pretty tightly. And then the next set is a little further apart here. And then the next set is usually even further apart here. So we want to stay as close to our vertex as possible, because the further away we get from our vertex, the further off the page we keep getting with our function. So I could either choose to the left, negative 3, and plug it in and figure out where it lands up here. Or I could choose positive 1 and figure out where it lands up here. Positive 1's the better choice because there's no negative and you are less likely to make a sign error, but you could plug in negative 3 if you wanted to. So we get 1 squared plus 2 times 1 plus 1. 1 squared is 1 plus 2 plus 1 equals 4. So over 1 up 4. Mirror it over, 2 units to the right it is now, so we're going to move it 1, 2 units to the left, and here is our parabola. And you want it to be, as oh, this is going to be really tough. You want it to be curved if you can, okay, not pointed. It's not an absolute value. It shouldn't look like that, nor should it come down and point and then go back. It's not a point here, it's rounded. It's approaching a certain spot and then turning directions. Okay, so try to round it out if you can. Okay, let's try one more. So scroll your page. And here we go. So here's the next one we're gonna try. This one I want you to pay very close attention to as well. And the reason is there is a negative right here, and it seems to mess everybody up. First of all, this one's headed downward because A is negative. That's good to note from the beginning. So A is negative 1, B is 2, C is 3. To get the AOS, opposite of b over 2a. Opposite of 2 is negative 2 over 2 times a, which is negative 1. So we get negative 2 over negative 2, which is 1. So my axis of symmetry is x equals 1, okay, which is right here. So here is my axis of symmetry, x equals 1, okay? Now let's find our vertex. We're going to plug 1 in, and we're going to do f of 1. This is where the problem lies. It's the opposite of x squared, 1 squared, plus 2 times 1, plus 3. The problem is that students oftentimes take that negative and put it inside the parentheses. The x term itself, okay, is here. And so the negative stays on the outside of those parentheses. You're taking what's in the parentheses and squaring it, and then you're going to take the opposite of it. Now this is the part that is the hardest part when doing these. This is the sign error problem. So remember I said recently that you should circle or use some strategy to remind yourself to do the square part first and then take the opposite. So if that's helpful, then do that. 1 squared is 1, and the opposite of 1 is negative 1, plus 2, plus 3, and so I get 4 for my answer. So over 1 up 4 from the origin puts me right here. That's my vertex, and I know that this one is opening downward. So the next thing that I'm going to do is find my y-intercept, 0, 3, and its reflection. So here's 0, 3, and its reflection. Okay, and then the last thing I have to do is choose a reasonable value for x. I'm going to get rid of this little spot I made. So we're going to go right ahead and choose a value. Again, since I have these 3 values, 0, 1, and 2, I can either choose negative 1 or I could choose 3 and plug it in and find out what the next value is. I'm choosing 3 since it's positive. The opposite of 3 squared plus 2 times 3 plus 3. So again, please remember to do the square part first. So 3 squared is 9, and you need the opposite of 9. Plus 6 plus 3 means that I get 0. So I get the point 3, 0. So over 3 up 0 puts me right here, and then I'm going to plot its reflection. So it's 2 units away from the axis of symmetry. So I'm going to go 2 units in the other direction, and then I have my parabola all graphed. And again, I want that to try to be rounded if we can. It's kind of tough, but there's your parabola.